Alright, so what we're going to do is take a look at that lab that we did where we took the magnesium metal, whoops, help if I had a pen, where we took that magnesium metal and we put it in a crucible and then we burned the magnesium, which was essentially reacting it with oxygen, and then we had that white ash in the bottom of our crucible when we were done, and that was the production of magnesium oxide. So what we want to do in this lab is show that the ratio of magnesium to oxygen in the compound magnesium oxide is a 1-to-1 ratio. Because remember, when we write a formula and there are no subscripts written, it's implied that those are ones. So what we're going to do is find moles of magnesium, moles of oxygen, and try to show that it's a 1-to-1 ratio. The first thing we need to do is figure out what our masses of magnesium, oxygen, and magnesium oxide are. So I'm going to use hypothetical data from the lab that I did. So when I weighed the magnesium, I found that it was 0.25 grams. And I don't know how much oxygen there was, but I can figure it out by knowing how much of the product there was. If I knew how much of that ash was in that crucible in the end, all I would have to do is subtract that and that to give me the oxygen. Because remember, the mass of the oxygen plus, the mass of the magnesium plus the mass of the oxygen has to equal the mass of the product formed. So when I have that crucible and that ash is present at the end when I'm done burning it, if I subtract out just the mass of the empty crucible, that would give me the mass of the ash. And when I did that, I found that the ash had a mass of 0.3 grams. Now notice, this mass has to be bigger than this mass. If that's not the case, in other words, you did the lab and your mass of your ash is less than the magnesium, what you should do is just double the mass of the magnesium and use that as the mass of the ash. That's hard to say. Alright, so when I subtract those two values, I'm going to get 0.13 grams of oxygen that reacted. So now what I want to do is I want to take my 0.25 grams of magnesium and I'm going to take my 0.13 grams of oxygen and I'm going to convert those to moles. Now notice, what I'm going to do is use oxygen just O. I'm not going to use O2, and we'll talk about that a little bit later as to why I did that. Alright, so let's do that calculation. Okay, so we're going to take our 0.25 grams of magnesium, and this calculation should be easy for you at this point. We're going to put grams in the denominator, and we're converting to moles. Again, the number with moles is 1. We go to the periodic table, we see that magnesium has a mass of 24. That way our grams cancel. And when we do the math there, we're going to get 0.01 moles of magnesium. We're going to do the same thing for oxygen, and if you remember, we had 0.13 grams, and again, I'm going to use just O. We're not going to worry about Y at this point. We'll talk about that later. The short answer is because in the formula, it's just O, it's not O2. So we're going to use just one oxygen. Okay. So we're going to have 16 grams of oxygen per mole of oxygen, and when I do that math, I'm going to get 0.008 moles of O. So what I'm going to do is take my moles of my moles of magnesium and my moles of oxygen, and I'm going to figure out what the whole number ratio is between magnesium and oxygen, and I'm going to see if it's a 1-to-1 ratio. Okay, to do that, all it is a simple math problem. We're trying to find the ratio of magnesium to oxygen. So to do that, I want moles of magnesium over moles of oxygen. So I had 0.01 moles of, I keep saying oxygen, magnesium. I had 0.008 moles of O, and when I do that calculation, what I get is 1.25. Now I always put that over 1, and it's just a reminder to me that I have 1.25, and that represents the moles of magnesium, for every 1 mole of oxygen. Now I need to make this a whole number ratio. And to do that, I need to multiply both of these by the same factor to make it a whole number ratio. So what you want to think is, what's the lowest number I can multiply 1.25 by to make it a whole number? And if you try 2, that won't work. 3 won't work. But what you'll notice is 4 times 1.25 is 5. And then, well, here, let me do it this way. Times 4 is going to give me 5 moles of magnesium. 1 times 4, 4 moles of oxygen. So I found the formula to be Mg5O4, which is close to Mg, which is close to the actual formula MgO, but again, that's the whole point of doing a laboratory exercise, is seeing how closely your data can come to some standard or known value. Alright, so again, the whole point of this lab was to figure out how many grams of this and how many grams of that we had, so we could figure out the mole ratio of magnesium and oxygen in the formula. What we're going to do in the copper lab is we're going to take copper, and some of you have already done this, and silver nitrate, and we're going to form products, and we'll talk about how we do this later. And when we balance this equation, we're going to have 2's, a 2 and a 2 there. So in this problem, what we're trying to do is prove the mole ratio of copper to silver in the formula. But in this lab, the magnesium, we're trying to prove the mole ratio of magnesium to oxygen. So this will be our next lab, which will do the same idea, but will form a different mole ratio.